This video covers the sewage and its treatment. Sewage is the liquid waste which includes human and household waste, industrial waste, ground waste, street washing, and stormwater. Sewage contains organic and inorganic matter in a dissolved, suspended, and colloidal states in water. So usually it is broadly classified like a domestic sewage and industrial sewage. The domestic sewage contains heavy load of biological oxygen demand, pathogenic bacteria, color, and bad smell. The contaminated sewage usually causes the following possible effect, that is depletion of dissolved oxygen, because the waste content which present in the water, that takes the oxygen, and thereby the oxidation process take place that reduce the dissolved oxygen content in that water. Color and smell affect the quality of water, and even the pathogenic bacteria which causes waterborne diseases. The domestic sewage need a proper treatment before disposal, and even this domestic sewage impart some characteristic. It has some characteristics, that is a physical characteristic, mainly what we observe, color and odor. The first domestic sewage is usually gray green to gray yellow in color and darkens as the time due to decomposition, and it develops an offensive smell due to the evolution of gases like hydrogen sulfide, ammonia sulfide, phosphine, and it is a turbid one, and even the temperature of the sewage is slightly higher than the ordinary water. The chemical characteristic, as you know, it contains a plenty of chemicals that depending upon the what type of chemicals we introduce to the water. The biological characteristic is due to the organisms, living organisms such as a bacteria, algae, fungi, protozoa. So as a result, it help for the oxidation process. The bacteria which carries the breaking of complex compound into a simple stable compound. Again, there may be anaerobic oxidation or aerobic oxidation that is brought about by anaerobic bacteria or the aerobic bacteria. Then now I consider how we treat the sewage water. Domestic sewage required proper treatment before its discharge. The treatment is usually carried out in 3 stages, that is depending upon the kind or the type of load which present in the water. Primary treatment, secondary treatment, and the tertiary treatment. Here, you can observe the primary treatments involves 4 steps, that is screening, slit and grit removal, then removal of oil and grease particle, and then sedimentation by coagulation process. Sedimentation by coagulation. Okay, screening. First thing is screening. The second, slit and grit removal, removal of oil and grease, then sedimentation. The screening, here you can observe the primary treatment. The screening in this method removes floating and suspended coarse particles. See, here it is a bar screen, or we may use, this is a bar screen. You may use a mesh screen also. Here, when the water passes through this bar screen, the heavier object, the floating objects and suspended coarse particles are retained on this bed, and the water which is free from this floating object is then fed into the next chamber, what we call it as a slit and grit removal. Sand, here continuously water is introduced to the slit and grit chamber. Sand, broken glass, etc. are removed by passing sewage through grit chambers, in which the velocity of flow of sewage is reduced. As a result, being heavier particles and grits are settled down at the bottom. Here it gets settled, whereas the water which is free from these particles are flow into the next chamber, what we call it as a skimming tank. A removal of oil and grease particles is usually done in a skimming tank. This is what we shown is a sedimentation tank, but in between sedimentation and this grit, we may introduce a skimming tank if the waste contains oil and grease. They are converted into SOP mixture by blowing compressed air through sewage water in a skimming tank. And these are lifted to the surface in the form of foam, and the floating substance is skimmed off. After that, the water is passed to a sedimentation tank, removes suspended impurities, This is brought about either by plane sedimentation or sedimentation by coagulation. The normally used coagulant are alum or even a ferrous sulfate, or even the plane sedimentation is nothing but just we fed the water in a large tank and keep as it is for a few days of period. As a result, the colloidal particles get settled at the bottom, and water which is free from colloidal suspended matter is removed. Whereas in the case of bicoagulation, we'll introduce the component like alum. Alum is a aluminium, like the formula is K2SO4, Al2SO4 thrice 24H2O. Alum we may introduce, or even a ferrous sulfate. The ferrous sulfate usually we will write like this: FeSO4 7H2O. Okay, helps for easy settlement of the molecule, this component, suspended particle. A calculated amount of coagulant solution is added to water, mixed thoroughly with water, and allowed to stand in a large sedimentation tank for few hours. So aluminium sulfate get combined with calcium bicarbonate forming aluminium hydroxide, or even ferrous sulfate forming ferrous hydroxide. This charged particle get neutralized the charges present on the colloidal particle, or the spongy voluminous precipitate entrap the colloidal particle and help for the settling process. Then these water which is free from these suspended or a solid floating objects, they are then passed through a second next to they are then subjected to the secondary treatment. The secondary treatment involves a extensive biological oxidation process. Involves an extensive aerobic oxidation, aerobic biochemical oxidation or aeration process. Here, the sewage water is subjected to aerobic oxidation, during which the organic matters are converted into carbon dioxide, the nitrogen into ammonia, and finally into nitrites. And if bases are present, they usually converted into ammonium nitrite, ammonium nitrates, calcium nitrate, etc. And this is done usually by trickling filter bed method or activated sludge process. In activated sludge process, the process involves extensive aeration of the sewage water, and the process of aerobic oxidation being enhanced by the addition of part of sludge from previous batch of oxidation, from the previous batch of oxidation process into the sewage water. Because the activated sludge contains a large number of aerobic bacteria and other microorganisms. The aerobic bacteria which present in the water, which helps to play a large complex, breaking the complex compound into a simple and a stable compounds. So these aerobic bacteria which live on free oxygen or on oxygen dissolved in water help for aerobic oxidation, and even which do not produce any offensive smell or any foul smell. The kind of oxidation is called as a aerobic oxidation. That is the oxidation that takes place in the presence of oxygen, called it as aerobic oxidation. So in an activated sludge process, you can observe a tank. A tank, what we call it as an aeration tank, where the oxidation of the process takes place. Here, the process involves extensive aeration of a sewage water. So activated sludge, here the activated sludge is mixed with the proper quantity of sewage water in an aeration tank, and the mixture which is sent into an aeration tank in which the air is continuously blown for several hours. So the mixing up of water with the oxygen take place. Here, this oxygen helps for the oxidation of organic matter which present in the water. So the organic matter usually be represented as a hydrogen, carbon, nitrogen, sulfur like component. On oxidation, in the presence of aerobic bacteria forming a stable compounds like carbon dioxide, water, or even nitrate components, or even sulfate components like components are formed. So that means the organic compounds which present in the water get oxidized, After the process, the effluent is then sent into a sedimentation tank, which helps for easy settlement of the deposit or the components like the colloidal particle. So here the the settling the particles get settled, and the water which is free from the organic matter are sent off. A clear effluent is collected, and the sludge, it is a portion of sludge is recycled. The water which is free from the organic matter is drawn off, and a part of sludge is fed into a sedimentation tank. It is mixed with again proper quantity of a sewage water. Okay, so you can observe the different types of aeration tank. Here air is introduced from the below bottom of the tank, and the mixing up of component take place, or the mixing up of oxygen with the water take place, and then it is fed into a sedimentation tank. So after the secondary treatment, here the sewage, how we conducted this activity sludge methods we explained here, and after the secondary treatment, the biological oxygen demand is reduced to about 90%, chemical oxygen demand is reduced to about 80%, and the total nitrogen is about 50%, and the phosphorus is about 30%. That means the total about 90% of the suspended part matters gets reduced. That means in the primary treatment we can able to remove almost all floating object, and in the secondary treatment we remove the suspended impurity. Even those fine particles present, or even we may observe some amount of disinfectant or the bacteria, so that is removed in the tertiary treatment. The water is further purified by tertiary treatment. In that, we observe the 50% of nitrogen present, and the 30% of phosphate is present. That is removed by adding calcium hydroxide. A flocculent precipitate of calcium phosphate is formed at a pH of 10 to 11. Ammonium salts are converted into ammonia. So we can represent this calcium hydroxide. When you introduce to water, it absorbs phosphate ion. It absorbs a phosphate ion and forming as a calcium phosphate, PO4 twice, calcium phosphate, along with the formation of hydroxyl ion. That means we can able to remove almost all phosphate molecule, phosphate ions. And even same way, when you add calcium hydroxide to water, the ammonium ion which present in water converted into ammonia, along with the formation of calcium and hydroxyl ion. Okay, so thereby we can able to remove phosphate in the form of calcium phosphate, ammonium ion in the form of ammonia. Then it is subjected to coagulation process, that is done by either coagulation by sedimentation, plain sedimentation, or sedimentation using coagulant. Coagulation and sedimentation, fine suspended particles are removed by sedimentation in presence of coagulant like alum, ferrous sulfates. So when you add a coagulant, so impurities which present in the water is a less dense particles. When you add a coagulant, the coagulant interact with the water and forming their hydroxide. Either it may be aluminium hydroxide or ferrous hydroxide. So this colloidal forms a precipitate, and that trap the impurities which present in the water. The fine particle help them settle down at the bottom. It's a one way. Other way, the particles, the added colloidal particles are charged one, aluminium hydroxide, positive and negative charge present. The charge get neutralized with the charges present on the colloidal particle, and easy settlement is possible. So this way, the fine divided particles are removed by settling process. Then it is subjected to filtration process. Water is usually passed through a filter bed to remove water is passed through a filter bed to remove last traces of suspended matter. We may introduce a conventional sand filter bed to remove the last traces of suspended matter. A conventional sand filter bed consists of three layers of sands, the gravels, coarse particle, and the top layer what we observe fine sand bed. So when we pass the water, the floating the objects they retained on the fine sand bed, and the water which is free from this small particles are collected at the bottom of the filtration chamber. Then the water is fed into a degasification chamber where we can able to remove almost all gaseous component. Here, stripping of ammonia and other gases is done in a degasifier. It consists of a large tubber with a large number of perforated plates. And these plates can consist of some catalytic component. When the hot water trickles through these plates, large surface area and higher temperature promotes stripping of dissolved gases like ammonia, carbon dioxide, hydrogen sulfide, etc. Then finally, the water is subjected to disinfection process. Among many disinfectants, the chlorine is a cheap and effective to destroy the pathogenic bacteria. It is normally used. There is a chlorine and the chlorine is most commonly used disinfectant. It can able to destroy the pathogenic bacteria. When we add a chlorine, it combine with the water forming hypochlorous acid. pH range 6.5. It can able to kill the bacteria. It is a good bactericide and can able to kill the bacteria. So this way we can able to remove almost all the unwanted impurities present in the water. Or you may introduce the other components like a bleaching powder. So that also remove. Unionized hypochlorous acid can kill the bacteria cell. The components of tertiary treated water, wastewater is BOD less than 1 ppm, ammonium less than 1 ppm, and phosphate is less than what we observed is a less than 1 ppm. So the treated water has high clarity, free from odor, low BOD, and therefore it is nearly equivalent to drinking water and can be recycled. The finally, what the water we collected, it is free from unwanted components. But during this process, we observe a production of large quantity of sludge. So the sludge is collected from sewage treatment process is disposed of by one of the following methods. The sludge can be dumped into sieve or land spreading method. The sludge is uniformly spread over soil. So after drying, it can be used as a fertilizer. And the third way of disposal is a septic tank treatment and sludge digestion. The sludge is kept closed in a tank for a prolonged period under aerobic condition. The product producing gases like methane. Under anaerobic condition, this process is carried out in the absence of oxygen. It forms methane, hydrogen sulfide, phosphate gases, and these gases can be supplied for power generation.